Okay, sir.
Good afternoon, one and all. Once again. So in last class we started discussion on complex number, right? So what are complex numbers? Anybody? So when we say that the number is complex number, yes, Vignesh.
Sir, when it is having this one, sir, real and imaginary.
Real and imaginary. Whenever the number is having real and imaginary, so we call it as complex number. So we denote it by small z, which should be equals to x plus iy, where x is nothing but real part and y is nothing but imaginary part. So now, in case if you want to represent this number diagrammatically, so how will represent this one? How we can represent this number? How we can represent complex number? So this is a two-dimensional number. One thing is the complex numbers are nothing but two-dimensional number, right? So two-dimensional means how many coordinates we should use? For example, if you considered any real number means it is one-dimensional number. Any quantity, any number you can take from the real number. So that's always indicates one-dimensional unit, right? So in case if you consider ordered pair some x comma y. So here, so first coordinate is x and y, second coordinate is y. So that means this is indicating two-dimensional number. Once if you come into vectors means that will be a three-dimensional number, right? So even you can represent the what is that vector in terms of order pair as x comma y comma z, right? So triple pair, you can write that one as triple pair. So that will indicate xi plus yz plus zk, right? So you can write in terms of triple pair as so just x comma y comma z. So in the similar manner, the complex numbers can be represented in terms of ordered pair as x comma y. So here the first coordinate will indicate the real part and second coordinate will indicate the imaginary part. So I told, so I is nothing but iota and it will be the value will be equals to root of minus one. So that means what will be the position of iota in terms of ordered pair? Can you guess? What will be the number? How we can represent this iota in terms of ordered pair? Anybody? How we can represent this number? Because based on that, even they may ask based on the property of iota itself. So that's why you should remember that thing. So iota, so that means if they given z equals I means what's the real part here? What's the real part? Is it having any real part in this number I?
No, sir.
No. So that means can we write this one as 0 plus I?
Yes, sir.
Can you write it as 0 plus I?
Yes, sir.
So 0 plus I means what is the real part? What's the real part?
0, sir.
0. And imaginary part?
1.
1. Right. So that means we can write this one as in terms of ordered pair as 0 comma 1. 0 comma 1. So now based on this iota properties means just you have to remember I square equals minus 1, I cube equals, we can write this one as I square into I which is equals to minus 1 into I which is equals to minus I. So next one is I power which is equals to I square into I square, and we can write this one as I cube into I. So I square value is -1 into -1, which is equals to 1. I power 4 is 1. So now, based on these three values, you can find out any power of iota. So for example, just I will take I power 100. So can you guess what will be the value of this one? I power 100?
1, sir.
1. How, Ignesh?
Even sol will become 1, sir.
Even power means
No, sir, like it will be 1, but minus we have to see, sir.
yeah, minus. How you will decide that one then? How we can decide? Just to say I power 100 is 1 only. So just I will consider one power, I power 50. If it is power, even power means if it is 1 means according to that, this I power 50 also should be 1, right? Is it
Yes, sir.
I power 50?
I power 50 also will be 1, sir, but that minus or plus we have to see.
Yeah, that thing I want clarification. Either it will be +1 or -1. So just based on that properties I square, iota cube, iota power 4, based on those three values only you have to decide iota power anything. So just I will take the one simple example. I power 7. What you can write this I power 7? Can you write in terms of
I power
into I power 3? Can you write? Is
yes,
it
sir.
same? I power 4 into I power 3. So just you have to add those two whenever base is same. So I power 4 plus 3 means it will become, once again it will become I power 7 only, right? So now we know the value of I power 4. I power 4 value is 1 and I power 3 is minus I. So that means I power 7 will become minus I. Is it clear this example? So now it's coming. Right?
Yes, sir.
Is minus I. So now, whatever power will be there, that thing you have to express in terms of power of 4. So is it 50 is divisible by 4? Is it divisible by 4? 50? 50?
No, sir.
No, sir.
Just to divide by 50. So 12 fours are 48, right? Minus 2. So that means remainder will be 2 will be there. So that means we can write this I power 50 as I power 48 into I power 2. Can we write?
Yes, sir.
So now I power 48. 48 is it a multiple of 4?
Yes, sir.
So
Yes, sir.
multiple of 4 means I write this one as I power 4 whole power 12 into I square value is minus 1. Can we write I power 48? Just I have written it as I power 4 whole power 12. So that means 12 into 4. Once again, it will become 48. Right?
Yes, sir.
So now we know the value of I power 4. What's the value of I power 4?
1.
1 power 12 into minus 1. 1 power anything is what?
1
1
only.
only, sir.
It's always 1 only. Right? So that's
So 1 is
so because we know the value of I power 4, 1, so every term, if in case iota power anything power is there means, first you have to try, you try to express that one in terms of power 4. And remaining thing you know, write it into multiple. So just I power 4, why we are expressing in terms of I power 4 means because we know the value of I power 4, it is 1. 1 power anything means we can write that one as 1. So we can simplify like this one. So I power 50 value will become -1. So similarly, I power 100 means we can write that one as I power 4. 4
Sir,
power.
or else we can write I power 50 into I power 50, sir. So -1 into
Yeah.
-1.
But
Become 1.
if you don't know the value of I power 50 means,
Okay.
right? So you should not try to remember all the values. Only try to remember iota square is -1, iota cube is -I, and iota power 4 is 1. Even if you are not remembering iota cube, iota power 4 also, at least you should remember iota square -1. By using those values, remembering value, you should try to express the given expression in terms of the noun things, right? So because here we know the value of I power,
Yes, sir.
we can write that one as I power 50 into I power 50. Right? Vignesh.
Yes,
sir.
sir.
So now
Yes, sir.
I power means what's the value? 1. 1 power 25 means it will be 1. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Okay, just I'll consider one more. I power 1007. Can you guess the value of this one? I power 1007.
-I, sir.
Minus I, right? So 1004, we can write that one as in terms of I power 4 into 2 power, I power 4 whole power 251, and remaining thing will be I power 3. I power 3 means minus I. Is it clear to everybody? Kirtana?
Yes, sir.
Okay. So now, just I'll consider one example, y equals x square. Right, so this is a parabola, we know this is a standard curve, right? So here the function will map set of real numbers to set of real numbers. The function will map reals to reals. So now, so just I'll consider one more function, f of z equals z square plus 3z plus 2. So where z is nothing but complex number. So here, what will be the domain and codomain? What will be the domain and codomain? You are putting what? F of z equals some function z square plus 3z plus 2 is there means. So you are taking the complex number. After putting complex number, what will be the outcome? Once again, it's in terms of complex number only. Right. So that means it will map from set of complex to set of complex numbers to complex number. So whenever the function is complex valued function, for example, you may take any complex number. If any function, if it is mapping to complex number, in that case, if you want to check the continuity means, because complex number means there will be two part will be there. One is real part and one more is imaginary part. In case if you want to check, so just you consider the standard one, x plus I. So this is the number z. So I consider f of z equals u plus ib. So in case if you want to check the continuity of this function f of z equals u plus ib means you have to check the continuity of real part separately and continuity of imaginary part separately. If both real part and imaginary parts are continuous, then you can say that the function is continuous. You know what's the definition and how to check the continuity for this set of real values. So here u is nothing but real function and v is also real function only, but it is imaginary part. So both are real means if individually you have to check, is it real part is continuous, is it imaginary part is continuous. If both are continuous, then we can say that the function is continuous. So after that differentiability, the same procedure you have to apply to check whether the function is differentiable or not. Just you have to check whether the real part is differentiable and imaginary part is differentiable, both are differentiable means then you can say that the function is differentiable. So based on differentiability, important concept, I already told the definition of that one. So that is analytic function. So analytic function means whenever the function is differentiable at that point as well as in the neighborhood, then we can say that the function is analytic. So if you want to say any function is differentiable means just you will check at that point, right? So but in case if you want to check whether the function is analytic or not, you will check at the point as well as it's in its neighborhood point. If it is differentiable even in the neighborhood point also, then we can say that the function is analytic function. So checking the function for the analytic or not, so based on the differentiability, it will be very difficult. That's why we'll go to the necessary conditions. Just we will check the necessary conditions whether the given function is satisfying the necessary conditions or not. In case if it is satisfying the necessary conditions, then we can say that the function is analytic. If it is not satisfying, then we can say that the function is not analytic. Anybody, can you say what are the necessary conditions for function to be analytic? What are the necessary conditions?
Continuous and differentiable, sir.
Continuous and differentiable means we can't say it is analytic. For example, so just I will take the function 1 by z. Is it continuous, Vignesh?
Sir, 1 by z, sir.
1 by z. F of z equals 1 by z. That is nothing but inverse function. Is it continuous? Is it continuous or not?
How to say it is
What, Vignesh?
continuous, sir? Continuous, sir.
Continuous. It's continuous only, even it is differentiable also. But at some particular point, the function is not analytic. Is it function will be defined for z equals 0? Is it defined?
Yes, sir. Will be.
At that point 0, the function is not analytic. Even it is not continuous at the point z equals 0, not differentiable at the point z equals 0. So that point is nothing but we call that one as some standard names for that. I'll tell later it. So to check whether the function is analytic or not, checking at each and every point, it's very difficult. That's why even I told what are the necessary conditions for a function to be analytic. Anybody remember what are the necessary conditions? Anybody? If f of z equals
PR equation, sir.
is a complex valued function, then is said to be analytic. Then it is said to be analytic if and only if first condition is it should satisfy CR equations. That is nothing but Cauchy-Riemannian equations. So now can you tell me what are CR equations? CR equations.
Dou u by dou x is equals to dou v by dou y, and dou u by dou y is equals to minus dou v by dou y.
Dou v by dou y and dou u by dou y equals minus dou v by dou x. So these are the two conditions we have to check the analyticity of the any function. So because checking the differentiability at each and every point, it's very difficult. So neighborhood means it will contains an infinite number of points. So that's why it's very difficult to find out at each and every point. Instead of checking all those points, just you can check this whether it will satisfy the CR equations or not. So this is the these conditions are nothing but CR equations are nothing but necessary conditions for a function to be analytic. Based on this, they may ask one question. The necessary conditions for a function to be analytic are like that. They will give the options dou u by dou x equals dou u by dou y and dou u by dou y equals dou u by dou x. First option. Second option, just they will what is that? Play with the signs. Second option, they may give dou u by dou x equals minus dou u by dou y and dou u by dou y equals dou u by dou x. Third option, right option like that they will give. Fourth option, dou u by dou x equals minus dou u by dou y and dou u by dou y equals minus dou u by dou x. So if you remember these conditions, CR equations, then only you can select that one. So that will be the direct question they may ask based on this analytic function. Is it clear?
Yes, sir.
So one more thing is, so these are the necessary conditions. That means, for example, if you are 20-year-old or in 19-year-old, then you are eligible for joining the, what is that, degree, right? So, but all 19-year-old students or guys can't, what is that, admit for the degree. So he should clear the 12th or plus 2. So that is nothing but sufficient condition. Necessary condition is what? So he should more than 18 years in general. Even if he got early admission also, at least you should more than 18 years, then only you will be eligible for taking the degree courses. So that is the necessary conditions like that. So these CR equations are nothing but necessary conditions. Even though if it is satisfying the CR equations, sometimes it may not be analytic. So that means the sufficient conditions for a function to be analytic are second condition. So these are nothing but sufficient conditions. That is the first order partial derivatives. The first order partial derivatives, that is this dou u by dou x, dou u by dou y, dou v by dou x, and dou v by dou y. So these functions should be continuous. So these first order partial derivatives should be continuous. Then we can say that the function is analytic at all points. So usually they will not ask any question based on this sufficient condition, because if it is satisfying the CR equations, means definitely almost all 99% they will give the functions in such a way that if it is satisfying the CR equations, means definitely it will be analytic. Like questions they will ask. So but you should remember, so these CR equations are not the sufficient. They are only necessary conditions. They may, what is that, they may play a little bit tricky question, means a direct question they may ask like that. Okay, in case if it is satisfying the CR equations also, sometimes it may not be analytic function. Just to keep it in your mind. Okay, so now just I will take you one example. So and you tell me whether the function is analytic or not. So just I will take f of z equals z plus 2. Is it analytic? Is it analytic? So in case if you want explanation, I will explain one problem. So first thing is what? We have to express in the real part and imaginary part. You have to note down the real part and imaginary part of the given function. So that means you have to note down the u and v. In this one we can write z means x plus iy plus 2. So just to separate the real and imaginary part, it will be x plus 2 plus iy. So this is the real part and this is the imaginary part. So that means u equals to x plus 2 and v equals to y. So now we got the real and imaginary part. So now we can check whether the function is analytic or not by finding out the partial derivatives. What's the partial derivative of u with respect to x? Vinesh? What is partial derivative of u with
x plus
x plus function is x plus 2.
2, sir.
A function is x plus 2.
It's a 2, sir.
2. Is it right, Kirtana?
Sir, 1.
The derivative is 1.
1.
Derivative of constant is 0. So that means the derivative of 2 will be 0 and derivative of x will be 1. So that means dou u by dou x equals to only 1. And what will be the derivative of u with respect to y? Dou by dou y.
X plus 2.
No, 0, sir. 0, sir.
Ah, x you will keep it constant.
So x is also constant. Whenever you are going to differentiate with respect to x, you have to treat y, you have to treat x as, so that means the derivative of constant will become 0. find out the dou v by x and dou v by dou y. Dou v by x will be 0. Dou v by dou y will be 1.
Answer.
So now you see these two are equal. So that means dou u by dou x equals dou v by dou y, and these two are equal with the opposite sign. If it is negative, 0 is there, means even you can multiply. What's that? Write 0 as -0 also. Nothing you are going to lose, right? So that's why it's satisfying the CR equations. Dou u by dou x equals dou u by dou y, and dou u by dou y equals minus dou v by dou x. So that's why we can say that this function is analytic function. Z plus 2 is analytic function. Is it clear?
Yes, sir.
Okay, so just I'll take one more example. F of z equals mod z square. So modulus of z square means, so if z equals x plus iy, then mod z equals square root of x square plus y square. That is square root of real part square plus imaginary part square. So that is nothing but modulus value. And complex conjugate z bar is x minus iy. Just you have to change the sign of the imaginary part. That will become complex conjugate of the any number. For example, if the number, if you have taken 1 plus 3i, means the complex conjugate will become 1 minus 3i. Minus 1 plus 3i means the complex conjugate will become minus 1 minus 3i. So this is complex conjugate. And in case if you want to find out modulus of any function is just to take 1 plus 3i. So square root of 1 square plus 3 square, which will be
That conjugate is fine, sir, but modulus of z.
what, Vignesh?
Sir, conjugate of z is okay, sir, but modulus of z will be.
Yeah, modulus of z is, so just you have to take square root of real part square plus imaginary part square.
Okay.
So just to take any number, what more number I will take? 5 plus 4i. Okay, for this one modulus will become, if z equals this much means modulus will become square root of real part. Real part is 5 square plus imaginary part is 4 square. So this will become the required modulus. Understood?
Yes, sir.
So now according to this one, we can write this mod z square as square root of x square plus y square whole square. So that means square root and square will get cancelled. It will be x square plus y square. So now note down the u and v. What's u? U is nothing but x square plus y square, and v is, what's the v value? What's the imaginary part?
Sir. 0, sir.
0. So now find out dou u by dou x. Dou u by dou x equals 2x.
2x, sir.
Dou u by dou
2y.
2y. Dou u by dou x.
0, sir. Both are 0.
Dou u by dou y also 0. So now is it satisfying the CR equations?
No, sir.
So that means the function mod z square is not an analytic function. So later we will come to know at which point the function is not analytic. Is it at which point the function is not analytic? Later, based on this, they may ask question. Even one question I noted down also based on this mod z square only. Is it clear? Since why the function mod z square is not analytic? So since the function is not satisfying the CR equations, so that's why the function is not analytic. Is it clear?
Sir.
That indicates that the modulus of the function is not analytic. One more function, so complex conjugate. So just I take f of z equals z bar. So now tell me if the function is analytic or not. F of z equals z bar.
So it will become x minus iy, sir.
It will be equals to x minus I. Real part is x and imaginary part is, what is the imaginary part?
0.
0. How come 0?
Sorry, minus I will say.
Minus
I will
y.
say.
I you should not take coefficient of y. That is minus y is the imaginary.
Yes.
So that means u will be x and v will be minus y. So now find out the partial derivatives. Dou u by dx is what?
1,
By dou y.
0.
V by dou x 0. Dou v by
Minus
dou
1.
y
Minus 1. Sir.
minus 1. Is it satisfying the CR equations?
Yes, sir.
Are you sure?
No, sir.
No. Dou
No,
u
sir.
by x is not equals to dou v by dou y. So that means the function is not satisfying the CR equations. So I'm using my ID only. It will get disconnect every 40 minutes. After that, once again, you join into the same meeting ID. Okay.
Okay, sir.
So how many minutes left out? I don't know. In so one case, if it is disconnected, means after that, once again, you join to the same ID. Just to keep it in your mind. So that means the function, what is that, complex conjugate is not an analytic function. Is it clear? So now I'll take the function, some any polynomial, some z square plus 3z plus 2. So I think I have already taken this problem, right? Z square plus 3z plus 2. So any polynomial in terms of z, it's always analytic function. Okay, it's always an analytic function. In case if the function, if you have taken rational function f of z equals z square plus 3z plus 2 divided by z cube plus 1 means the function will be analytic everywhere except at the zeros of the denominator. Okay, for example, zeros of the denominator means z cube equals minus 1. Right, so this is the zero of the denominator. Except at this value, that means z cube should not be equals to minus 1. Except at that value, at everywhere in the complex plane, the function will be analytic. Okay, so just in case if the given rational function means, and if they ask us to find out the whether the function is analytic or not, so just you have to check, are they mentioned any, what is that, domain which is excluded from the zeros of the denominator. At all the points of the domain which excludes the zeros of the denominator, the function will be analytic. And all analytic, what's that, polynomials are analytic functions only. Even all trigonometric functions also analytic functions. Is it clear?
Sir, sir, 1 minute, sir. Like z power minus 2, that also.
Z power minus 2. If you have taken z power minus 2 means we can write this one as 1 by z square. Right?
Yes, sir.
So at which point the function is not defined? At which point?
At z power 0, sir.
Z equals to
0.
Right. So z equals to 0 is nothing but what's that? 0 of the denominator. So that means except at the point z equals 0, that function will be analytic everywhere. Only at the point z equals 0, the function will not be analytic. Understood?
Okay, sir.
Okay, so based on this, they may ask one question based on this analytic function, and few more concepts are there. So I'll discuss few problems based on this analytic function, and then I'll continue on to next concept. So in 1 minute, we will get disconnect. So if you have any doubts, just to think and ask me based on this analytic function. So just to glance it, what are the analytic functions? What are the necessary conditions for a function to be analytic? How we can check whether the function is analytic or not by using the CR equations. So this much if you remembered, it will be more than enough to solve any problems based on this concept analytic function. Even they may ask direct questions like CR equations, based on CR equations, like necessary conditions for a function to be analytic, like that. And they may ask by giving the one function whether it will satisfy the CR equations or like not, like that also they may ask direct questions. By giving the function, they may ask whether the function is analytic or not. In that case also you should check
Okay, sir.
whether the function is satisfying the CR equations or not. Yes, Vignesh?